In this video, I'm going to explain the solid revolution, volume of a solid revolution. When we rotate the area that made by the the graph y is equal to 3x and x-axis and 0 to 2 here, this for this function, this is the next question, and I got the figure from that question. When we rotate this one around the x-axis, we will get one three-dimensional figure, which is also cone here. And the volume of this one, for finding the volume of this one, we are going to use the formula pi times integral a to b. This is the point A and this is the point B. It's going to be fx squared dx. Why we are going to use this formula? Let me explain simply like this. The area of the circle, we know that it's equal to pi r squared. And here we have infinitely many areas, and all the areas has same same radius. What is the radius of them? If this value is x, this is the y it's going to be. So the radius here, it's going to be y, which is equal to pi times y squared is the area of the circle. It's going to be infinitely many circles. If there are here, when we get them together, the volume becomes integral volume, because when you put over and over again these areas, you will get one volume, like the pages of the books. Pi times fx squared it's going to be. But this is not the volume, this is area. And if you do this one from a to b by using the integral, then it becomes the volume of three-dimensional figure. Okay, then if we solve this question, here the boundaries are given. It starts from this point, which is equal to 0, from 0 to 2. This function rotated around the x-axis. And how to find this one? If it is rotated around the x-axis, it's going to be first dx, and the volume of the figure is equal to pi times from 0 to 2 fx squared dx it's going to be. And volume of the figure is equal to pi times from 0 to 2 fx squared, here it's equal to 3x squared, it's going to be dx. And volume of the figure is equal to pi times from 0 to 2, it's going to be equal to 9x squared dx. What is the integral of 9x squared? Volume is equal to pi times 0 to 2, 9x squared volume is equal to 9x cube over 3, and the boundaries are 0 to 2, and volume is going to be equal to here pi 3x cube from 0 to 2 it must be. Then the volume it's going to be equal to pi times here 3x cubed, 3 times, you know, this part from the definite integral, x cubed, it's going to be equal to firstly 2 cubed, then 3 times 2 cubed minus 3 times 0 cubed, and volume is equal to pi times, it's equal to 3 times 2 cubed, it's equal to 27. 3 cube is equal to 2 cube is equal to 8 times 3, 24. Pi times 24, the answer is going to be equal to 24 pi. To check this one also, I can prove this one by using the volume calculation. Here the next subject it's going to be stereometry, and in the stereometry the volume of the cone it's going to be equal to 1/3 of pi r squared times h. It should be the 1/3 of this cylinder. It's going to be here, this is the h and this is the R it's going to be. In this figure, the H value it's going to be equal to, from this point to this point. If I rotate this one, it's going to be equal to 2. And here the function is 3x, that's why the value here, it should be, when it is x is equal to 2, y it should be equal to 6. That's why the radius length is equal to 6. Here R is going to be equal to 6. So the volume is equal to 1/3 of pi times r squared is equal to 6 squared. 6 squared times 2, it's going to be, volume is equal to 1/3 of pi 36 times 2. 36 and 2, 3, if you simplify, this is going to be 12. Volume is going to be equal to 24 pi. So I prove by using the integral it's 24 pi, or if we calculate the our volume of the cone, it is equal to 24 pi. Okay, then here we have the figure, and the function is x squared plus 2, and this function rotated around the x-axis from 1 to 2. So directly the volume is equal to pi 0 to 2. The function is x squared plus 2 squared, it's going to be, and dx. So if you remember, a plus b parenthesis squared is going to be equal to a squared plus 2ab plus b squared. So I'm going to use the formula here, pi times integral 0 to 2 x to the power of 4, because x squared is equal to x to the power of 4, plus x squared times 2, which is equal to 4 x to the power of 2, and the last one, it's going to be equal to plus 4 dx. It's going to be, I made a mistake, I didn't recognize that one, but I made a mistake while I was writing the boundaries. Here the boundaries are 0, 1 and 3, it's going to be 1 and 3, it's going to be here this value and this value it is, and the boundaries I'm rewriting 1 to 3, 1 to 3, it should be. Okay, after this correction, let's continue our question. Pi times x to the power of 4, it's going to be equal to x to the power of 5 over 5, plus 4 times x to the power of 3 over 3, plus 4x from 1 to 3, it's going to be. Then volume is equal to okay. Here, when we have rotation around the y-axis, we will get the formula only square f squared dy. We have to get the function in terms of, actually here it is written gx, consciously it's written here is it gx, because this gx function, when you rotate around the y-axis, becomes f. So I'm going to try to explain while we are solving the question how it's going to be. Now the function is equal to, y is equal to 3x minus 1, but when you rotate around the y-axis, you have to write the function in terms of x, which means y is equal to 3x minus 1, y plus 1 is equal to 3x, y plus 1 over 3, it's equal to x going to be. So the function fy here, it's equal to y plus 1 over 3. And the boundaries are, volume is equal to pi times, boundaries are 2 to 5, y plus 1 over 3 square dy it's going to be, and the boundaries are 2 to 5. I explained that one. It's going to be equal to, volume is equal to pi times integral 2 to 5 y plus 1 square over 3 square dy it's going to be, and that's equal to pi times 1 over 9 times integral 2 to 5, because this value is, it's not going to affect operation, y plus 1 square y plus 1 square dy it's going to be, which is equal to pi over 9 times integral 2 to 5 y square plus 2y plus 1 dy it's going to be, is equal to pi over 9 times, now we are going to get the integrals of the y squared, which is equal to y cube over 3 and plus 2y squared over 2 plus y, the boundaries are 2 to 5 it's going to be, and